Hello and welcome you all. This is Professor Rajesh Barapate, a book author of 25 plus engineering books. Dear students, today's topic is magnetism. I will tell you simple tricks how to solve the numericals related to magnetism. Students, if you haven't yet watched the earlier video, that is prerequisite required for entire subject, then please watch that video because all the basic concepts will be clear to you. So I will provide the link of that video in the description box. So without wasting the time, let us dive into the topic. Before starting solving the numericals, I will explain you the different things which are very much required for the solution of these equations. There are some electric terms, everyone knows it. I represents current, V represents voltage, R represents resistance. Resistance is opposition to the flow of current. Voltage is also called as some external force which is required for the electricity, and I is the electricity, that is current. Corresponding term in magnetism are related to current I, we have to consider magnetic flux phi. Then related to voltage, corresponding term in magnetic field is MMF. It is also referred as magnetomotive force. Magnetomotive force. And corresponding to resistance, one term is there which is called as a reluctance. It is denoted by S, but the basic remains same. Now, you need to memorize only these equations in order to solve any numerical. If you just watch this video, it will be hardly for 8 to 10 minutes. You will be in a position to solve any type of numerical based on magnetism. Now, as I said, you need to memorize these equations. Only few equations are there. Mu is called as permeability. What is this permeability? Every medium has a tendency to oppose the things passing through it. So, the tendency of a medium to oppose the magnetic lines to pass through it is related to permeability. It is expressed as mu 0 into mu r. Mu 0 is called as permeability of free space and mu r is called as relative permeability. Value of mu 0, that is permeability of free space, that means opposition of the free space for magnetic lines, is fixed value, which is 4 pi into 10 raised to minus 7. Next is MMF, that is magnetomotive force. Just now I explained this MMF is similar to the voltage in electric field. So MMF is given by N into I. N represents number of turns. I is current passing through the wire. I will explain this in more detail while solving the numericals. S is the reluctance. Reluctance is related to resistance in electric field. It is given by L. L is the length upon mu A. A is the cross-sectional area. One more extra term I have written, that is H. H is the magnetic field intensity. It is also called as strength of magnetic field, which is given by N. N again number of turns, I current, and L, small l, is the length of particular wire. As I mentioned, we'll discuss these notations while solving the numericals. Now, remaining formulae you can generate it by using the basic things. How to do it? According to Ohm's law, we know the basic formula. Current in electric field is V upon R. You might have studied this equation, V is equals to IR. This is the basics Ohm's law. If I want to make use of, or if I want to generate similar equation for magnetic field, how can I do it? Look at this formula. Current is similar to magnetic flux phi. So I can write phi is equals to voltage is equivalent to MMF. So it is MMF, magnetomotive force. And R is similar to S. S is the reluctance. Reluctance is opposition for the flow of magnetic flux lines. So one more formula I have generated without mugging up the things by using basics Ohm's law. That is phi is equals to MMF upon S, where S is the reluctance. Now, if you want to further simplify it, we already written MMF, that is magnetomotive force, is N into I. So this same equation can be well written as Ni upon S, because in place of MMF, I have put the value Ni. if you want to obtain equation of S, that is reluctance, from this same equation, then very simple, consider phi is equals to Ni upon S. So if I will transfer S over here, S can be written as Ni upon phi. From this equation I have generated it. So only these formulae are required to solve any numerical related to magnetism. So let us solve few numericals to get an idea how to make use of these equations. Now we will solve one numerical. Coil is wound with 300 turns. Now do remember the basic things. While reading the numerical itself, go on writing the different notations. For example, how I am reading it, a coil is wound with 300 turns. Number of turns are denoted by N. So given N is equals to 300. On a steel ring of mu r is relative permeability. So mu r is also given, mu r is 900. It is relative permeability, it's constant, so there is no unit. Similarly, there is no unit for number of turns. It has mean circumference of 40 centimeter, 40. Now, do remember, mean circumference of a ring is similar to the length of ring. So, length of ring is denoted by small l, it is 40 centimeter. Always keep in mind, we have to do the calculations using SI units only. So, centimeter is not allowed, I need to convert it into meter. So, when you write the given things, at that time itself, convert it into meters. So we know 1 centimeter is 10 raised to minus 2 meters. That's what I have written. Next, it has a cross-sectional area of 5 centimeter square. Cross-sectional area is denoted by small a, which is 5 centimeter square. Again, this given unit is centimeter square. We have to convert it into meter square. Dear students, one common mistake you need to avoid. As I said, 1 centimeter is 10 raised to minus 2 meters. So this, if you will try to convert it into SI unit, that means in meter square. So only 5 into 10 raised to minus 2 is not sufficient because it is centimeter square. That means I need to take 10 raised to minus 2 square. So keep in mind like this. If area is given and centimeter square equation is given, you will have to convert into meter square by multiplying it by 10 raised to minus 4. So it is 5 into 10 raised to minus 4 meter square. This is the value of A. A is the cross-sectional area. What else is given in the question? It has, a coil has a resistance of 100 ohm. So resistance, usual notation, R is equals to 100 ohm. And supply is given as 250 volt. Usual notation V, that is voltage, is given as 250 volt. All these are the given quantities. I have written these given quantities by using the notations, and don't make mistake. Always and always try to convert centimeter into meters, centimeter square into meter square by multiplying it by 10 raised to minus 4. Alright, now about the first part. As I said, only this set of formula is sufficient to solve any numerical on this topic. So first calculation, coil MMF. MMF is magnetomotive force. We have this formula of MMF. Earlier we have written this formula. Now question arises, which formula I need to choose. Whatever given things are there, always and always try to choose the formula related to given quantities. So look at the first formula. MMF is N into I. N is number of turns, but I is not given. I can be calculated very simply because resistance is given and voltage is given. So what I will do, first I will calculate I using the basic formula. I is equals to V by R, that is 250 upon 100. This will give me the value of I, which is 2.5, and it is I, that is current. So unit I have written it as an amperes. So this is the value of I because I am using first formula, N into I. Why not second formula, that if I will transfer S over here, then it becomes MMF is equals to S into phi, but phi is not known, S is not known. So I am using this formula. Okay. So I have calculated I. Write the basic formula. MMF is equals to N into I. This formula I am using. N number of turns 300. 300 into I, that is 2.5. So do this calculation. The answer will be 750. Question arises, many students are mugging up the units. You don't have to mug up any unit. I will tell you simple trick. I have calculated MMF. Which formula I use? This N into I. N is what? Number of turns. Number of turns. And I is what? Current. So current is measured in amperes and N is measured in terms of number of turns. So unit is written as ampere turns. AT. Ampere turns. Actually, it should be turn into ampere, but the convention is write it as ampere turn. Okay. So this is the first part. What I did, I have calculated the value of MMF, which is 750 ampere turn. Second calculation. What is asked? Field strength. Field strength is similar to the magnetic field intensity. Do you remember these words? So field strength is similar to the magnetic field intensity, which is denoted by notation H. Check out the list of formula. Which formula is available to calculate H? We have this formula, Ni upon L. Just now we calculated the value of I. Value of L, that is length, that is circumference, is known. So you just have to put the values. So you will get H. I am using this formula, Ni upon L. N is number of turns. Number of turns are 300 into current. I have already calculated 2.5. This value divided by L. L is the length. I need to put the values in terms of SI unit. So 40 into 10 raised to minus 2. You just have to perform these calculations on the calculator. So answer will be 1875. Again question arises. How to generate the units? Again I am repeating, you don't have to memorize the units, don't mug up the units. Which formula I used? Ni. What is the unit of Ni? Same as unit of MMF. That is N is number of turns measured in turns and I is current, so it is ampere turn. AT divided by L. L is the length. SI unit of length is meters. So it is AT upon M. M, that is meters. So this is the basic equation or basic formula to calculate the value of H, which I got the value as 1875 ampere turns per meter. Third calculation. Third calculation is, it is asked to calculate the reluctance. Now, how to do the calculation of reluctance? Again, check the formulae, available formulae. See, I can well use of this formula. How I decided, why not this formula? See, to make use of this formula, I need to know the value of flux. Flux is not given. So what I will be doing, I will be using this formula because everything is known. If I use this formula, L upon mu A. And one more thing, in place of mu, I need to make use of this value mu 0 mu r. So formula to calculate reluctance becomes S is equals to L upon mu 0 mu r into A. Look here, it is L upon mu A. Mu is mu 0 into mu r. So what I wrote, L upon mu 0 into mu r into A. So L, length is given as 40 into 10 raised to minus 2. Just put the values 40 into 10 raised to minus 2 divided by value of mu 0 is fixed 4 pi into 10 raised to minus 7. Mu r is relative permeability, which is given in the question. So mu r is 900. Put the value 900 into area. Area is 5 centimeters square. Use the value 5 into 10 raised to minus 4 meters square. If you perform the calculation on the calculator, answer will be 707.35 into 10 raised to 3 into 10 raised to 3. What about the unit? Now, how to write the unit? See, as far as this formula is concerned, you may be thinking like this. L is the length measured in meters, mu 0, mu r are constants, then A is meter square. I will tell you one simple thing. As far as reluctance is concerned, don't try to write the units making use of this formula. Consider this equation to write the unit of reluctance. Even if I am not using this equation, but for generation of units, do remember this equation. N number of turns, I ampere, so it is ampere turn divided by flux. Unit of flux is Webers. So this unit is 80 ampere terms upon Weber's. Weber is expressed like this, WB. Once again I will repeat. While writing the unit of reluctance, make use of this basic equation of reluctance, that is Ni upon phi, just for generating the unit of reluctance. So this is the third part we did, that is calculation of reluctance. Next part is, it is asked to calculate the total flux. Now, total flux is denoted by notation phi. Look at the set of formula. These are the available formulae. So we can make use of any formula like S just now we have calculated. MMF, we have already calculated value of MMF, that is magnetomotive force. So we can make use of this equation, MMF upon S. S is the reluctance. We have this value of reluctance. We have already calculated the value of MMF. You just have to put the value of MMF. MMF was 750 upon S, put the value 707.35 into 10 raised to 3. So answer of flux is 1.06 into 10 raised to minus 3, and unit of flux is Webers. You can well write this answer as 1.06 milliweber, because this quantity is multiplied with 10 raised to minus 3. So I have expressed it in terms of milliwebers. This is the calculation of total flux phi. Now last part, permeance. This is the new term for you. See, reluctance is opposition to the flow of magnetic field. Permeance is reverse of that. Permeance means, think like this. It is giving permittivity for the magnetic flux to pass through the medium. So permeance is 1 upon reluctance. So it is 1 upon S. S is the value of reluctance, which we have already calculated. Just put the value. So this answer of permeance will be 1.4137 into 10 raised to minus 6 into 10 raised to minus 6. What about unit? Very simple. This is the value of S, that is the value of reluctance. I am taking reciprocal of this. Take reciprocal of units. So it becomes, unit is Weber per ampere turn. So this is one numerical we solved just to get an idea how to make use of the formulae. The first numerical, we did the calculation of 5 different quantities. Actually, from the exam point of view, sometimes 2 or 3 quantities are asked, but to get an awareness of making use of formulae, I have solved that lengthy numerical. Let us discuss one more numerical. Iron ring of mean circumference of 140 centimeter. What I said earlier, while reading the question itself, you need to write the values in terms of notation. So mean circumference is 140 centimeter, that is L. Mean circumference is L. It is 140 centimeter. Convert it into meters. So it is 140 centimeter. That means it is 140 into 10 raised to minus 2 meters. Then a cross-sectional area of 12 centimeters square. Cross-sectional area is small a, it is 12 centimeters square. Like the previous sum, it is 12 into 10 raised to minus 4 meters square. Is wound with 500 turns of wire. So number of turns are 500, number of turns are capital N, so N is 500. What is the relative permeability of iron? Relative permeability is denoted by mu r. So it is asked to calculate mu r. If existing current 2 ampere is flowing in the coil, current is given, that is I is equals to 2 amperes. Produces flux of 1.2 milliweber. This small m is milliweber. So flux is denoted by phi, which is 1.2 milliweber. Now, as we discussed in first numerical, express all the quantities in terms of SI units. So I need to write this as 1.2 into 10 raised to minus 3 Webers. We know the basic formula. 1 milliweber is equals to 10 raised to minus 3 Webers. So I have expressed the quantity in terms of SI unit, that is Webers. Now, how to do the calculation of this term, that is mu r? In this question, it is asked to calculate the value of mu r. Refer the given quantities. Very important part while solving any numerical is proper choice of the formula. So A, L, N, I and phi, these values are given and it is asked to calculate value of mu r. So I need to refer the formula which contains the term mu. Refer all this formula. We have the term mu in this formula, that is S is equals to S is equals to L upon mu A. So first I will write this formula. S is equals to L upon mu A. Keep in mind, this mu is mu 0 mu r. So I can well write this formula as L upon mu 0 mu r into A. But the question arises, I need to know the value of S, that is the reluctance. So before that, I need to calculate mu r. So first I will express the terms in terms of mu r. I will transfer this mu r term over here and S term at the RHS. So simply I can write, if mu r is transferred at the LHS, it becomes mu r is equals to L upon S into mu 0 into A. What I did, this S I have transferred here and mu r is transferred at the LHS. So mu r is equals to L upon mu 0 S into mu 0 into A. The question arises, I don't have the value of S, then how to think, how to calculate value of S? Again refer the given quantities and think, how can I make use of S? See, I can well make use of this equation because see, I have the formula of phi. Phi is mmf upon S, or Ni upon S. I is given, N is given, phi is given. So from this I can calculate the value of S. The same thing I have written over here. That means if you want to calculate S, directly you can make use of this formula. S is Ni upon phi because all the three quantities are given. So I have this equation, S is equals to Ni upon phi. Now directly you can put this value of S in place of this at the denominator term. So equation can be written as mu r is equals to L upon Ni upon phi. This value of S I have written into remaining quantities mu 0 into A as it is. So if you solve this, so before that we will just put the values. So L, value of L is 140 into 10 raised to minus 2 upon N, number of turns 500, into current is given as 2 amperes upon phi flux is 1.2 into 10 raised to minus 3 into value of mu 0, as we discussed in the last sum, mu 0 is constant, it is 4 pi into 10 raised to minus 7. This value is already written in this set. So into 4 pi into 10 raised to minus 7, this value of mu 0 I have put, then into A is 12 into 10 raised to minus 4. You just have to solve this equation on the calculator and answer will be 1114.08. This is the value of mu r. Since mu r is relative permeability, which is a constant term, there is no unit. Dear students, I have explained you how to solve the numericals on magnetism. Just do remember this set of formula. You can solve any numerical related to this, and once again don't try to mug up the notations or units. It is nowhere required. Just by referring the formula you can generate the unit as per your requirement. So that's it for today's lecture. Thanks for watching this video. If you haven't yet subscribed the channel, please subscribe the channel and keep studying. Thank you. Thanks a lot.